Okay. Good morning, everyone. First of all, I would like to thank our respected lecturer to provide us an opportunity to explain or discuss our wireless sensor network design, which was created to a smart greenhouse. These are
We can't hear you.
before I start, am I audible, sir?
Yeah, now audible, yes.
Okay. Okay, before I start my presentation, I would like to explain some of the basic things what you mean by a greenhouse. Normally, we refer greenhouse. We normally use a greenhouse to provide a control environment to the plants which we are going to plant in this environment. This greenhouse will monitor and manage the environmental humidity level and temperature level, as well as the soil moisture level and the normal. We need to provide the lighting setting as well. But when we in a traditional greenhouse system, when we monitoring those things in a manual manner by using the human efforts, sometimes it can be give some errors, or it can be challenging one, because sometimes human errors or improper maintenance can be damage the plants and the other its growth as well. For that purpose, we have proposed a smart greenhouse system that will be that system can be remotely monitored and be managed by a system, and these all the environmental conditions, that means greenhouse environmental condition can be monitored by using the sensors such as soil moisture detection sensor, temperature and humidity sensor, and light detection sensors. By using those sensors, we can properly get the input from the environment, greenhouse environment, and according to based on those parameters or data, we can properly provide the humidity, adjust the heating level, and provide the irrigation system and light setup. For that purpose, we have proposed a automated greenhouse system. For that purpose, we have selected a hypothetical greenhouse which will be made from the glass and boards, and this will be our greenhouse blueprint. Our greenhouse will contain two major rooms, one for potting shed area, that will be a small room. We have planned to plant or start our seedings in this area up to some point. After plants are growing up to that some point, we will shift those plants into this greenhouse area. This will be a large room that will be contain 3 major plant beds. And according to that, since we are planned to design a smart greenhouse, we plan to use ZigBee technology, because since to design and implement our wireless sensor network, we have planned to use ZigBee technology, because we didn't select other technologies, wireless sensor technologies such as Bluetooth and the other Wi-Fi technology, because this ZigBee is an open standard, as well as it's a low cost one, and also this consume low power when we compare to other 2 technologies, and also this process in low data rate. Since these wireless sensors are provide low data rate, and it's need to run a long run. For that purpose, we have selected this technology to design our wireless sensor network. And also to design and simulate our wireless sensor network, we have used OMNET++ 6.0 version. And this when we working with this OMNET++, we need to have some basic knowledge in C++ coding as well. And I will explain our sensor placement and actuator placement. Actually, in our wireless sensor network design, we have planned to use 14 sensors, but some limitation in the OMNET++ and some visual constraint. In our design, we only place 5 sensors. I will explain other sensors location as well. In our potting shed area, that means in our potential area, we plan to place 4 sensors. One sensor is for the humidity and temperature sensor, and other sensor for the light detection sensor, and other 2 sensors will be for the soil moisture detection sensor. And also in our greenhouse major area, that will include 3 major plant beds. For each plant bed, we plan to use 2 moisture detection sensor to get the proper moisture level, accurate proper moisture level to the system. According to that, since there is a 3 plant beds, we need to have a 6 soil moisture detection sensors. As well as in this large room, we plan to have 2 humidity and temperature detection sensors and 2 light detection sensors. Because we plan to have 2 light detection sensors, since this is a large room, and while plants are growing, that will create some shadows and darkness. So that purpose, to properly get the proper light inputs, environmental light inputs, we plan to have 2 light detection sensors. As well as to design a wireless network, in our wireless network design, we have used star topology. Since it's a small greenhouse environment, we plan to use a star topology. In a star topology, all the sensors and actuators are connected to this controller, and through this controller, all equipments are communicated. So we have placed this controller in a central location where all other equipments, that means actuators and sensors, can easily access to this controller. And for that purpose, we have placed this controller in a central location where all the sensors in this both room can be easily communicated. And also we have used a router, because since we are planned to use develop a smart greenhouse system, we need to provide the accessibility, or we need to provide the accessibility to the internet, because we plan to use a cloud-based greenhouse monitoring system. So since its major files are located in the cloud base, we need to communicate, or we need to connect this Zigbee wireless sensor network with the internet. For that purpose, we have need a gateway between this wireless sensor network and the internet. For that purpose, we have placed a router here. And let me explain another important thing is, when we selecting these sensors and controllers for this design, we need to, since we are going to use the Zigbee network, we need to properly select the equipment which we support to this Zigbee technology. For example, if we take the controller, there are many kind of controller available in this market. For example, if we take the Arduino company product, there are many controllers are available to develop IoT based system, but all those IoT based controllers are not supported to this Zigbee based wireless sensor network. There is a controller called Arduino XB Shield that only can be used for this wireless sensor network. Likewise, there are many companies develop or design many controllers which we support to this Zigbee kind of wireless sensor network. We can select such kind of a wireless sensor network controller to this. And when we selecting other sensors like humidity and temperature sensor and light detection sensor, and as well as the soil moisture detection sensor, we need to select the sensors which is support to this Zigbee controller. And let me share our simulation part. Since some limitation in our time, we have recorded the simulation part, and this is the OMNet Plus environment. In this, you can see to design this in this environment, we have used IPv4 IP addressing protocol to provide IP addresses for each devices, and also we have used CSMA-CA acknowledgement method, since all the devices are communicating through a controller to avoid the collision between the devices. And you can see all the devices are connected through this central controller. That means when a device try to share its data to the network, this star topology network, that will send the data or acknowledgement signal to other devices to avoid the collision using CSMA-CA. And all the communication will be run through this controller. For example, in this workbench area, if a soil moisture detection sensor sense less soil moisture level in that area, that will send the signal to controller. Controller read those data, and with the predefined parameter, that will send the signal to the irrigation system to start the motor and provide the water supply to the plants, needed plant area. And also by using this Omnet++, we can evaluate the power consumption level as well. For example, okay, in this table, you can see the power consumption level of each and every equipment which we have used in our wireless sensor network. You can notice that the controller consumes more power than other equipments which is placed in this wireless sensor network, because since we are using a star topology, each and every time when a sensor communicate, or when there is a transaction data communication is occur, it will run through the controller. So each and every time that sends the acknowledgement signal, as well as it's received the other data from the sensors.
Okay,
and
please finish in 5 minutes. Huh?
Okay, it sends the data to the other equipments. So that purpose, this controller run more than other equipments. For that reason, this controller consume more power than other equipments in the wireless sensor network. Since we are using a Zigbee technology, we can properly manage this power as well. That's all from our part. And yeah, that's all from our part. If you have any questions or clarifications, you can ask. Thank you for listening.
Okay, if you have a question, you can ask from her. Okay, very good presentation, and they have done the coding also. You can see some software development can come in this area, right? So you have opportunities. Okay, very good. And you send me an email that what is your group and what is your name also, the student number, right?
Okay, sir.
Okay,
Thank you.
right. Thank you. So another group?
Yes, sir.
Okay. What is your group?
Samita, can you share the screen?
Okay, what is your group?
We are extreme fighters, sir.
How much marks you got?
87, sir.
You might be the highest, I think. No? Yes. Okay.
Yes, I think so, sir.
Right.
Okay.
Okay.
Hello, good morning, everyone. So our group name is Extreme Fighters. So this was our presentation. We mainly picked this topic because we felt like this warehouse one has many visible applications as opposed to the greenhouse one. But I'm not exactly sure if that's the actual case, but we picked this one anyway. So yeah. So here we have separated the solution into several sections because that way we can easily split up the work among the team members. But in the actual use, these operations are not isolated from each other and they work very seamlessly together. So yeah. So my part was warehouse inventory management. Now let's see it in detail. Okay. So here we have the basic plan of the warehouse. We created this plan mainly because in order to place the Wi-Fi access points, you need to create a plan. So yeah, that's the main reason why we created this. So here, first we have the inbound area. So this is where the goods come into the warehouse. And then we have our first conveyor belt here. And this belt is mainly responsible for taking goods to the sorting area. And sorting area is the place where the product sorting process happens. And then we also have second conveyor belt. And this belt is mainly responsible for taking goods to the outbound area. And outbound area is the place where the goods are taken away from the warehouse using trucks. And then we have storage area, office room, quality assurance room, control room. And control room is mainly responsible for controlling and monitoring the data we obtain from various sensors. So yeah, that's the basic plan of the warehouse. Now let's see how item input works. Okay, so here's what I'm proposing here. So I'm proposing to install RFID and weight sensors near all the 2 conveyor belts. And then we will also place a camera above the conveyor belt number 1 And then this camera will also have some AI task. So I'll come to this in a second. And additionally, employees can also use their handheld readers to update the inventory as they wish. So now let's see how item input works using a diagram. Okay, so this is the item input. So as you can see, as these boxes move through this conveyor belt, their RFID tags are captured, weight is measured, photos are taken, and then it gets updated to the inventory in real time. So now let's see a slightly different scenario. Okay, so this is another scenario. So suppose some items comes without any boxes at all. So in a situation like this, we have to classify the items first before adding them to the inventory. And in that case, we can use a pre-trained model to identify the products, and then we can classify the item. And then after that, we can add them into the inventory management's relevant categories. So I have to mention that I made one assumption here. The assumption is that we already know what products we are getting. Because if we don't know what products we are getting, then we cannot train the model this way, since we need the pictures of the item to train the model. That's the only catch here. And to train the model, you can use a library like YOLO or TensorFlow like that. And as for the security here, we can use API with some authentication to protect the request. Initially, we didn't have any idea about the security and stuff, but in the Vivas, it was pointed out to us by Sudarshan sir and Tilak sir that we have to be mindful about the security also. So yeah, now let's see item outbound. So this is item outbound. So this is where the goods are taken away from the inventory. So here, as these boxes moves away, these sensors communicate with the system and tell whether the order is correct or wrong. So yeah, that's how item outbound works. Now let's see product quality assurance. Okay, now let's see it in detail. Okay, so initially this part was done by our teammate Penusha. So as we all know, quality assurance is very critical for perishable goods because you need to store them using a good standards, because otherwise they will go bad. Now let's see what he's proposing here. So here's what he's proposing. So he's proposing to place various Zigbee sensors in the warehouse. And then these sensors communicate to the common gateway, and then through this gateway we can receive the sensor data and control them as we like. So this way it doesn't matter what the sensor is, because whatever the sensor is, if it is Zigbee, then it will work in the same manner like this. And when it comes to the security here, Zigbee already have encryption built in, and that's AES 128. Okay, so here he's proposing to place air quality sensors, light sensors, temperature sensors, dust sensors, likewise in the warehouse. And these sensors ensure that product quality is properly maintained in the warehouse. And to keep the warehouse clean, he's proposing to use vacuum robots on a schedule. And also use UV robots to disinfect the warehouse from time to time. So yeah, that's the end of the product quality assurance part. Now I'll hand over to Nisha.
Thank you, Gihan. Now I will conduct transport and management and fleet management from now on. Actually, this part was done by our team member Samita, and he was proposing to use Zigbee sensor inside the vehicle, and those sensors communicating to the gateway. From there it gets to the cloud in transportation management. In our proposed solution, we have to choose to utilize Zigbee technology for several reasons. These include high reliability, cost effectiveness, low power consumption, and high security. Zigbee devices are designed to consume low power, reduce the need for frequent battery replacement by replacing the necessary Zigbee sensors. Inside the transport vehicle, we can collect data and make informed decisions. For example, we can measure the temperature and humidity inside the vehicle using IoT devices, and helps to communicate this data wirelessly with the warehouse. And let's move on to the fleet management. In fleet management, we are basically talking about the 5 categories. First, let's go to the vehicle health and productive maintenance. Installing telematic solution or OBD based solution can be used to check the vehicle health, as well as IoT help to monitor the accurate and it prevent any problem by predicting with the help of gathered data, as well as IoT sensors gathered info about the fuel consumption, fuel level, tire pressure, engine temperature, and runtime of the vehicle. It will help to acknowledge the maintenance team when to get any maintenance to the vehicle. Actually, this is compared to the manual maintenance done by human IoT help to reduce manpower, as well as the accuracy of the data is very high if you use IoT to check the vehicle health. And the real-time GPS monitoring. Since it's about the customer's trust, the service provider should be responsible for delivering the food item or any package in the real time without delaying or without happening any damage. That's why we need to replace the RFID tag for GSP tracking. The RFID tags are placed on trucks, containers, or any assets to be monitored during this transportation. We can use RFID tags and GPS asset tracking to get the data such as location, time, data, or any take through if occurred. As well as in driver's behavior reporting, we suggest to use smart bracelet. As we all know, it can be used to get the driver's conditions such as body temperature, blood pressure, and heart rate. Then we can actually add the sensors to adjust the vehicle inside pressure, because we all know that when it comes to the hillside routine, air pressure can be changed and it can cause to the make sudden cardiac arrest. As well as we suggest to put the AI to check the monitor of eye movement of the driver randomly within 30-minute time lapse or 15-minute. It will help to reduce the accident which occurred during the driver's drowsiness. If we connect that IoT to make an automatic buzzing alarm, then driver get the notification when to get the rest. In fuel management system, we suggest to use GLTV7 fuel sensor, and this is used to measure fuel level mostly. It can detect the difference in fuel levels and it connects to the GPS tracking system of the vehicle, and it can directly replace the fuel or fill the tank when the level goes down. We suggest to put IoT devices when it comes to door accessing and controlling. With the help of IoT devices, we can put the RFID tag that only allow driver could open the door with the help of providing tag. We suggest to use IoT to beep an alarm when the third party tries to open the door. Also, we can install AI system to detect faces that can be monitored online in real time with the help of IoT automatic processing. It can be included in the system such as turning on trucks inside light when the door open and sending notification to the main branch or warehouse notify that the door was opened. As well as we should put the sensor to adjust inside the temperature when the door is open, as well as the recording things happen when the door is open. In real-time scenario, the fleet management mechanism would have the architecture that can be also seen in the top diagram. The IC responsible for the successful delivery of the request from the user of the vehicle and the successful delivery of the response from the vehicle to user. Then it will be helped to perform diagnosis through the onboard diagnosing. And the second diagram, you can see the hyperterminal software is going to play the role of company's vehicle, and the LabVIEW application is going to play the role of Zigbee coordinator and the users. The communication between the two programs is going to be feasible through the computer serial port. The user will be able to read and write the information to the hyperterminal through the special function within the LabVIEW program that is specially designed for the communication with the devices through the serial port. In our case, instead of a device, we have the hyperterminal software. That's it for fleet management. And data analyzing and reporting. Actually, this part was done by teammate Pamin Shah, and she was proposing to get the data from all the sensors and make various reports to help with the decision making. That's it.
Okay, thank you very much. There are uses many sensors. So they have done a lot of study. It's a very good presentation and very good assignment. Any question you have to ask from her? Okay, you can send me an email, your group and the names of the people who have done the presentation. Okay. Okay, next
Okay.
group.
So
Okay.
we are tech boomers and
Okay.
we'll be doing next.
Okay, good. How much mark you got? Marks?
83, sir.
Okay, very good.
Okay, so respectable lecturer and my dear colleagues, and good morning, everyone. First of all, I am Sanjita, and this is our topic, an IoT-based automatic irrigation system for a smart greenhouses. So let's get started from the team members. So these are our group members, and now you can see the presentation lineup. So when you complete our presentation, you all can able to understand the introduction part. So the background study of this particular research and the problem statement, proposed solutions. And when we need to go for some proposed solutions, definitely we should need some required components and system designs and the discussions and the conclusions. Okay, so without wasting time, first we need to go for the introduction part. So based on the earlier mentioned problem, that means the IoT devices that we need to do the smart greenhouses. So we have to propose one particular system for the greenhouses. That is, we are referred to use the IoT-based automatic irrigation systems. The fundamental idea is to increase the yield of vegetables, fruits, and the crops through use of modern technologies. This particular proposed IoT-based smart greenhouses farming system, here we are using some temperature, humidity sensor, and soil moisture sensors with the help of different type of sensors as well as the actuators. So here, in order to assure the future efficiency, definitely we should need these type of research technologies to be deployed, as well as in developing economy like Sri Lanka and having less money, we can't afford such huge systems. So hereby a greenhouse IoT-based systems is a very best example and efficiency way to grow up the vegetables and fruits and our other things. Okay. Another background study. So before we need to go for that one, now we need to let's focus on our first sub questions as to be explain how sensor networks can be effectively used in greenhouses. Okay. So here the sensor networks, it's improve the control of technology of a greenhouse environment with the use of environmental automated control technology. That is an efficient way to enhance the control technology. That means where we can use our sensor networks, that mean sensors, actuators. So what are the things, what are the boards that we can use? And the second one is scalability and reconfigurability. Scalability in the sense where we can additional nodes and sensors can be added to the network with a little effort. As well as the reconfigure, that means we can make some changes in order to the individual nodes within the network. So likewise, there hasn't been a lot of studies done on the topic. Definitely this particular study quite restricted some of the areas in before study in the last 10 years. So there has been a surge in the interest in the use of sensor network in a greenhouses. It's more benefit for the in this area. So based on this all, our problem statement is the agricultural sector lacks smart solutions that assist farmers in automatically controlling the irrigation systems of greenhouses. Okay, so let's focus on our proposed solutions. So when you talk about this IoT-based unique wireless sensor network system, it utilizes the IoT and the wireless sensor networks and the cloud computing. And let's merge it together, integrate that all, and it helps the user to choose an irrigation profile. And it can be in the irrigations. We can set weekly or otherwise monthly irrigation plan. Definitely, we should use mobile applications or otherwise web applications. In our case, we are proposed to use the mobile applications. And we can manually activate or deactivate the water pumps that we can use the humidity sensor, or we can use the temperature to control the temperatures, and we can use the soil conditions at a given time, and that all we can use within the single mobile applications. Okay, now I conclude my part, and the next part will be continued our group members. Thank you.
These are our component required sensors. We select LM35 temperature sensor for heat temperature from greenhouse, and we use soil moisture sensor for get soil details from greenhouse, and we use humidity sensor for get humidity details on air inside the greenhouse. So yeah, we'll move to next slide.
Okay, go ahead, please.
I hand over to suddenly continue our presentation.
Okay, Sanjita, can you move to the earlier slide, please? We missed a slide there.
This one?
Earlier one, actually, the components required actuators. Okay, so Malisha was explaining about the sensors that we were using, and then here we have highlighted the actuators that we are going to use. The fan to switch it on when the temperature is high, and then the motor and the water pump in order to facilitate the water supply or the irrigation system in the greenhouse, and then repeater to extend the Wi-Fi facility, and then the OLEDs display. And as the microprocessor, we are using ESP32, and to get the wireless connectivity, we are using a Wi-Fi module. Next slide, please, Sanjita. So here I would like to draw your attention towards the system design, and basically we are talking about the workflow of the system here. So now you already know the IoT devices, the sensors and the actuators that we are using here. So those things are referred to as the IoT devices here. So then the readings or the inputs that we are taking through the IoT devices here are transferred to the IoT hub. So this IoT hub acts as the messaging platform, which is hosted in the cloud. So it is the central message hub for the bidirection message or the communication between the IoT applications and the devices that it manages. So the data that passes through the IoT hub will be analyzed, and then these stream analytics will be directed to the Power BI dashboard with the highlights of the analysis. At the same time, those data would be transferred to the SQL database as well. So through this SQL database, the mobile application or the user will be able to read out the real-time data that is relevant to the humidity, moisture, and the temperature through this mobile app. At the same time, when we're talking about the working of the our proposed solution, we said that the user can manually control different kinds of things using the mobile application as well. For example, if the user needs to activate the water pump, without making it activated automatically, the user can simply turn it on through the mobile application. So then that command also will be updated in this SQL database, and same as earlier, the data flow will go in the opposite direction through the IoT hub to the IoT devices. So that is the main workflow of the system. So next, let's move to the system block diagram. So here, as you can see, we have the ESP32 as the central microprocessor, and power supply is connected. And especially with regard to the power supply, we are planning to power this unit using solar panels with the aspect of utilizing the concept sustainable energy. And also here you can see the 3 sensors connected to the ESP32 as the soil moisture sensor, humidity sensor, and the temperature system. In the opposite side, you can see the Wi-Fi model, which gives the wireless connectivity to this module. And through the relays, we have connected the 3 actuators, and these relays will guarantee the reliability and the safety of our devices. And here you can see the system architecture. So here we have used MQTT broker as the to manage the machine-to-machine communication. So with regard, we are proposing to use Node-RED. And as you can see, we have the subscribers and the publishers, respectively, the sensors and the actuators. So they will subscribe to a specific topic. And accordingly, the data communication between these IoT devices would happen. So that is basically the system architecture of proposed solution. So I finally invite Jani to justify the wireless technologies that have used in this proposed solution.
Thank you, Sandali. Let's move to the wireless sensor networks. Actually, I'm going to explain about the wireless sensor network that we have used here. Wireless sensor network consists of large number of small, low-power wireless sensor nodes that are distributed throughout the greenhouse and connected to a central control system. Here, as the communication protocol, we have used Wi-Fi. There are a few reasons for selecting Wi-Fi as our communication protocol. One reason is there is high speed of data transfer, which can help the growers to quickly identify and address any issues there. The second reason is facilitates for remote monitoring and control. By using a mobile application, growers can remotely monitor and control their greenhouse operations from anywhere at any time. The next reason is enhanced data visualization. Mobile applications can offer data visualization tools such as graphs and charts that allow growers to easily understand the data and help a decision-making process. As well as it facilitates for cloud storage and analysis and integration with other systems such as climate control systems or irrigation systems to provide a comprehensive greenhouse automation solution. Could you please move to the next slide? Okay, the steps. Implementing a wireless sensor network in a greenhouse involves several steps. The first step is to define the requirements of the wireless sensor network, which includes identifying the types of the sensors, need to measure the environmental parameters and determine the desired level of accuracy and precision. Then we went to the selecting of a hardware for wireless sensor network, which includes selecting the types of the sensors, wireless communication protocol, microcontroller, and the power supply. Then sensors need to be installed at appropriate locations throughout the greenhouse, such as different heights and different zones to ensure the comprehensive coverage of the environmental conditions. Third step is configure the wireless sensor network, which includes setting up the wireless communication protocol, assigning unique IDs to each sensor nodes, and configure the data transmission rates. Fourth step is testing and validation, and finally integrated with a control system to automate greenhouse operations. We need to connect with actuators and a specific control system. Next slide, please. Okay, in conclusion, the integration of smart wireless sensor network with mobile Wi-Fi technology has shown great potential in enhancing greenhouse management system. And when talking about the future directions for the development of more sophisticated algorithms and data analytic techniques can be used here in order to enhance the performance of this type of systems, and further research can be done on the environmental and economic impacts of wireless sensor networks with mobile Wi-Fi for greenhouses. So that's all our presentation. Thank you very much for listening us. If you have any questions, please ask.
Okay, thank you very much. Very good presentation. And send me an email, your team, name, and the members who presented with their student numbers. Okay. Yeah. Okay, if you have any question, you can ask from them. So they have thoroughly studied. I think all these presentations are very good, and they did a very They did a very good teamwork and hard working also. Okay, next presentation. Okay, your team name and the marks you got. What is the team next doing? Okay, are there no any teams? So those who have done good presentations today, I will consider when I am doing the overall marks. That also, right? I think I asked to do how many groups? 5 groups.
4 groups. Sir.
How much?
4 groups.
4 groups, yeah. Okay. 4th group is not there.